Hey everyone, thank you so much for tuning into BayTutors Intermediate Advanced Programming, Day 5.
We're excited to have you guys here today, and we have exciting material prepared for you guys.
Okay, so to start off today's session, Arnav will be going over the worksheet from Wednesday.
Yeah, so if we take a look at the worksheet, mainly focus scanner reading and like file writing and stuff. So the first question asks us, write a method that will prompt the user to enter a password and do so until they enter a correct password. And once they do so, print out correct. And it says the correct password is passed in a string correct pass, and then we can do so with all of this. With this method, so let's go ahead and copy paste this method header into Eclipse. All right, so the method specify they want to prompt. First of all, we want to prompt them to enter a password, and that's the first thing we do. So here we'll obviously use a do while loop, since we want to ensure this happened at least once. So we'll go ahead and make a do while loop. So while, and then we'll have a condition. But the first thing we'll need to do is create a scanner. So we'll say scanner sc equals to new scanner. We'll pass in system.in, since we're taking input from the user. And then also we have to import the scanner class, as that is, it's not like, it's something that we need to import. So we'll go ahead and do that with this import statement up here. And then we'll go ahead and store a temporary variable called string guess. And the first thing we'll do is we'll say do system.out.println, enter a guess for the password. For example, that's just our prompt, and it is good practice to have a prompt, as we said. And it looks like there's an error for this. It's actually system.in with the in not capitalized, so that was my bad. And then here we can see we printed out the prompt, and then next we're just going to do sc.next, or actually we're going to store a guess equals to sc.next. And then that basically just stores the user's guess into this variable. And then we'll go ahead and say while guess is not equal, well guess. So since this is a string, we can't use the equal comparison. We actually have to use the dot equals method. So we'll say while guess dot not equals to correct pass. We'll continue to iterate through this loop, and then we'll go ahead and do that. And then finally, once they do enter the correct password, we'll print out correct. And that is basically it for this question. So basically we have a scanner, and then we have a temporary variable for guess. And then while they don't enter like a correct password, we continue to prompt them with the do while loop. So that's the first question. Now let's move on to the second question, which says, using a scanner, write a method that counts the number of words in any given sentence and returns this value. The sentence won't have numbers of, like, the sentence won't have punctuation that is separated with a space, and the sentence will be passed in with a string parameter. So here's the method header. We'll go ahead and copy paste that into Eclipse as usual. And then we'll go ahead and use a scanner for this question, since we can next token, which is very helpful, and that's a useful scanner method that we can implement in this question. So we'll go ahead and say scanner sc equals to new scanner, where we pass in sentence, because again, remember, the scanner class has different constructors. If we look at the API, we can actually pass in a string as the constructor, and the scanner takes that in. And we also want to have a temporary integer variable that we increment as we count more words. So int word count equals to 0. So for now it's 0, but then we'll go ahead and say while sc dot has next. And we want to go ahead and say word count plus plus. And basically, and then we'll go ahead and just do sc.next to ensure that we like move on to the next token, and we don't stay on the same token forever, and we don't run into an infinite loop. But basically, the reason we use the while statement here and ensure that there is an sc.next so that we don't run into an error where we actually don't have a next token. So if we actually put it in a while loop and ensure that there is actually a next, we won't run into any errors. And then finally, we can return word count. And that's the second question. And for the last question, it says, given a sentence, write a method that writes the actual sentence as well as the number of words it has to a text file. The first line should contain the sentence and the second line should contain the number of words it has. So for calculating the number of words, we're supposed to use this previous method, and we should name the file sentence.txt. Okay, so let's go ahead and copy paste the method header. And I believe it's header previous question, so it's in the sentence. And then the first thing we want to do is create a file writer object. So file writer, let's just call it writer equals to new file writer, where we name the file. For example, I think it specified we had to name it sentence.txt, so we'll go ahead and do that. So we'll name it sentence.txt. And here we can see throw an error because we didn't import the file writer class, but we can simply just import it and the error will disappear. So the question specified that the first thing we want is sentence to the file. So we'll do write where we pass in sentence. Oops, I spelled that wrong. So, but then since we want to separate it into two lines with the first line sentence and the number of words it has, we'll actually and then /n. That way we can ensure that it actually separates into two separate lines. And then right after that, we can say int num words equals to word count, where we pass in sentence. And that's basically just the number of words the sentence has, and that's pretty simple. So we can call the method with that. And then we can also do writer.write num words. And then finally, we have to also close the writer. Like we have to close the file writer, because if we don't close it, then we'll be thrown an error. So we'll say writer.close. And that's basically this question. But if you notice, everything is throwing us an error right now. And that is because we actually didn't like surround it with a try catch. So we'll go ahead and put all this code around the try catch. So we'll say try, and then we'll try to do all of this, but then we'll catch and like an exception. So we'll say catch exception E, and then if we do catch an error, we'll just say system.out, and that just prints the message of the error. And this way, our code is error-free since we surrounded it with a try catch. And with that, we can move on to the rest of today's agenda.
Okay, so thank you, Arnav, for reviewing the worksheet. And now for today's agenda. So we're going to start off by going over abstract classes. Then we'll be giving an introduction about recursion. Then we'll be looking over some recursion problem solving methods, and as well as giving a live coding demo using recursion.
Mm-hmm. So the first thing we'll be taking a look at is abstract classes. So let's go ahead and do that. So an abstract class is basically a class that either has some or all methods defined as abstract. And abstract classes are generally more vague and don't have specifics defined, and it's up to the classes that extend from them to implement this. So the header for an abstract class is actually very similar to that of a normal class, but instead of like just naming it public class name, we have the keyword abstract. So we call it public abstract and name class. And then similarly for methods, we actually just have a very similar protocol for naming, where we say public abstract and the return type of the method and the method name, and then any parameters that the method might have. And note that methods that are abstract don't have any code in them, and only the method header is defined. So this is kind of like back to yesterday where we looked at interface, where the methods in an interface don't have any code defined. And this is kind of like the same for the abstract method, where you don't actually have any code defined, but it's up to the methods that or the classes that implement them to define the code. And note that an abstract class is more of a blueprint for other classes. And you can't actually create like classes from an abstract class. You can't actually create objects, but it's more of a blueprint for a class. And earlier we compared it to an interface where the abstract methods don't have any code in them. But the difference between an abstract class and an interface is that an interface is like 100% abstract, which means that the methods in them are not defined. So that means that the methods in them don't have any code in them, but instead we just declare the method header. Whereas in abstract classes, they can be between 0 or 100% abstract, which means that some methods can actually have code defined, whereas their methods just have the method header. And that's really just a different abstract class interface. All right, so now take a look at, yeah, let's pause for questions. So if you do have any questions in the chat, or you can unmute yourself and ask that. All right, so it looks like we don't have any questions, so we'll move on to like a quick example of an abstract class. So here's an example of an abstract class called animal. So animal is just a class where we have, it's an abstract class. So we have one method called public abstract void sound. And this is just a method that other classes can implement since we don't actually have a body for the method, but instead we just implement the header. So clearly we know that this is an abstract method that other classes can implement. And then the second method that we have in here is not actually abstract, but it simply just prints, it's called public void add to world, and it prints out added to world when called. So know that this second method over here is not actually abstract, but the first one is. And the second method, since it's not abstract, we actually have to declare something, and we have the method body implemented. So now on the right side of the screen, we can see a class that actually implements this abstract class called animal. So we have public class dog extend animal. And the first method in it is public void sound, which is implemented from the abstract class. So here we actually take that method that we declared in the class animal, and then we go ahead and declare it in the dog class. So when we call, so for their implementation, we simply print out woof as this is the dog class. So that's our implementation for this method. And then the second method we have in here is actually just the main method where we construct a dog object. And then we go ahead and call the sound method, which is this. And then we go ahead and call the add to world method, which is declared in the animal class. And then once we do both of them, we can see that in the console, we print out woof and add to world, is that's how we declared the method. So that's basically just an example of what an abstract class is, an example of how we can implement it. So if anyone has any questions, feel free to type it in the chat or unmute yourself. And look, we have any questions, we'll move on to the next slide.
All right, so
which is an introduction to recursion.
Yeah, so now I'll be giving an introduction to recursion in Java. So just a generic overview of recursion without going into like specifics and all. Recursion is basically, oh, okay, Arnav, I believe Angshu asked a question. Arnav, are you there?
Oh yeah, sorry, I was muted. So Angshu asked, why do we need to use abstract classes in the first place? And that's actually a very good question. And abstract classes are kind of like interfaces, like we mentioned in the previous class. So in abstract classes, we actually just define the method headers, and that kind of creates a blueprint for other subclasses that we might have. So although it might not make sense on a smaller scale, when we have many like other classes that extend from it, It's actually just, it makes the code much more organized, and it has a system that we can implement, and it makes it easy for the user to like understand.
Yeah, so it's basically the purpose is sort of just like interfaces as Arnav mentioned. It just helps like provide a generic layout for a class that other classes can extend, and they can like have their own manipulations to that particular class. So suppose like you want to create like a person, for example, right? Like a person abstract class. Then from that person abstract class, you can like have different methods, right? That define different attributes of a person, and there's different types of persons as well, people as well. So that's the purpose of an abstract class, just to, like just keep it super generic so that other classes can extend that and sort of make them more custom to what they want to do. So it's sort of just like a simple blueprint for a class. Okay, Angshu, does that answer your question?
Yes, sir.
Okay, good. Okay, so now we'll be talking about recursion in Java. So a generic overview of recursion. So recursion is basically a process, right? And if you look at it in code, it's basically where you will see the method call itself, right? Until it meets a certain condition that stops the call. So within your method will basically call itself. So it'll be calling the method within its method a certain number of times, right? Or for as long as possible until a certain condition is met, at which it'll stop calling itself. And it is basically a form of problem solving that can often, help you with turning really complicated problems into a very simple solution. And it's really useful, but at the same time, it will take time to sort of, understand and really grasp the, what you're actually trying to do. But once you understand it, once you're able to understand what recursion is and how it sort of works, it is a very efficient and helpful tool that is key in Java programming, because it really helps turn complicated problems right into simple solutions. Yeah, so now if we're diving into more specifics of recursion, so introducing new terms and all. So basically, as I mentioned before, it occurs when a method calls itself to basically solve another problem. And with each recursive call, right, with each time it calls itself, the problem itself becomes more simpler. And this is because it starts to approach a base case, right? So it becomes more simpler and then starts approaching a base case. The base case is basically the condition, right, or the endpoint of where your solution to the problem can be calculated, right? It's basically that condition that stops the call. You can sort of think of a base case as like, if you're thinking about like a for loop and the limit, that just helps you think of it like a little bit easier, how there's a limit, right? If the number is, like equal to your limit, then your for loop will stop, right? If you specify that it should just be less than your limit. So you can think of the base case sort of as like a limit, but it's basically the endpoint of your recursive calls. And it is basically where the solution can be calculated after you reach the base case. And recursion involves the internal use of a stack. And a stack is basically a data abstraction where okay, 1 second, sorry. Leave something else open. So Okay, so a stack is essentially a data abstraction where new information is added. And it's basically added to the top of the stack. And then as information is removed, it is popped or removed from the stack. And recursive calls are all stored in the stack, and they're manipulated in a similar manner. So Arnav, if you could produce the animation right now. Yeah, so this is essentially what a call stack will look like. So as you can see, if we were to pass in, like suppose we want to calculate the factorial of a certain number, we would pass in factorial of 5, right? And what factorial of 5 would do is it would go down. And we'll be going over this into like the next couple slides on problem solving the recursion. But the main idea is that when you pass in factorial of 5, the method will call itself to call factorial of 4, and that gets stacked on top of the call of factorial of 5. It'll just keep on getting stacked up as you make more recursive calls. And then in the end, it'll just work backwards after you reach the base case. So as you can see, the base case has been reached by factorial of 1. And once it's reached in factorial of 1, it'll use the value of factorial of 1 and then work its way back. So that's sort of what a stack is sort of in Java, and it's in recursion, and we'll be going into more detail in the next couple of slides. Angshu? Yes. Angshu, we'll be covering arrays and all that stuff later on. Okay, so Arnav, next slide, please. So with the stack, and just with recursion in general, there are some pitfalls. One of the pitfalls is that if your recursion never reaches the base case, meaning that your base case is unreachable, um, then your recursive calls will continue to run until your computer runs out of memory, which will cause it to crash the program. So you do not want this to happen. So and like, how do you know, right? How do you know that your recursion is never reaching the base case, right? And how do you know that your computer's run out of memory? And this is usually indicated by a stack overflow error that will be produced or given to you, or a heap storage exhaustion error. That's basically given to you when your computer will run out of when your recursion will never reach its base case. You have to ensure that this will not happen. And one way to do that is to make sure that after each recursive call, your algorithm is moving you one step closer to reaching the base case. So these are just some things to keep in mind, that you always must specify a base case in recursion.
And again, as Nani mentioned, with you like you have to reach the base case, otherwise you'll like be thrown error. It's kind of like if you have an infinite while loop, you want to make sure that you don't have that, and then you actually do work towards something that terminates the loop or the recursion in this case.
Yep. Okay, so next slide. All right, so that was just a really basic overview of recursion. So if you have any questions, please feel free to ask them in the chat. That was just more of just like the background of what recursion is and all. And now we'll be actually showing you the logic behind solving recursion problems. And Arnav will be giving coding demos. So if you have any questions, please feel free to ask them in the chat right now. Or you can unmute your mic and ask them. So no questions? Okay. So now we'll be going on into recursion problem solving. So there's two beginning common recursion problems. One of them will be a factorial problem and a Fibonacci sequence. So these are two really basic common recursion problems that you'll find usually, and they help provide a solid understanding, right? A solid foundation for recursion in Java. So we'll be going through solving each one of these, both in logic as well as in code. So now we'll be talking about the factorial recursion problem. So if you're looking at this logic, right, of a factorial in Java, and just factorials in general, right, they are the product of an integer and all the integers below it. So for example, capping off at 0. So if you were to look at 4 factorial, 4 factorial is equal to 4 times 3 times 2 times 1, right, which is equal to 24. And 3 factorial is equal to 3 times 2 times 1, which is equal to 6. So this is what a factorial is in Java. Just in general. And our goal, right, for developing a factorial method is that we want to make a method, right, that can compute the factorial of a given number int n, which will be given as a parameter to our method. And we want to recursively call the method itself within its method. And then we want to return the current number, right, multiplied by the factorial of the number below it, for all numbers that are greater than 1. So if we look at our algorithm for this method, you can see that our algorithm is equal to n, right, which is the current number, times factorial of n minus 1. And then our base case, right, our base case will be when n is less than or equal to 1. So that's going to be our base case. So if n is ever less than or equal to 1, we're just going to return 1, because you know that the factorial of 1 is 1. So if n is ever less than or equal to 1, or just plainly equal to 1, that's going to be our base case where we will not return, where we will just return 1. So this might be a little bit confusing, but let's sort of look at how the logic plays out. So if you look at the first line, right, it says fact of 4, right? Fact is the name of the method, factorial, and then 4 is int n, right, the n parameter. So fact of 4 will return 4 times of fact of 3. But then fact of 3 is equal to 3 times fact of 2. And we're doing this by looking at our algorithm, right? Our algorithm is n times factorial of n minus 1. So it's 4 times fact of 4 minus 1, which is 3, and so on. So fact of 3 is equal to 3 times fact of 2. Fact of 2 is equal to 2 times fact of 1. And fact of 1 will actually return this to 1 and not 1 times fact of 0. So that's actually an error. That's actually equal to fact of 1 will just give us 1, because our base case, right, is n always has to be less than or equal to 1. So if n is ever less than or equal to 1, right, then it's going to return us 1. But but for everything else, if n is greater than 1, then we're going to be returning n times factorial of n minus 1. But since fact of 1, in fact of 1, n is equal to 1, so therefore we'll be returning 1 there. So please disregard what is there right now. And so how this works, right? So as you go down the list, right, you're saying, okay, it's 4 times 3 times 2 times 1. That's what I want to accomplish. So on, if you can put the animation right now, you can see the table. All right. So this diagram is a great representation of how it works. So the initial call is fact of 4, right? And as you're going down, we see fact of 4 is equal to 4 times fact of 3, as we mentioned. Then fact of 3 is equal to 3 times fact of 2. Fact of 2 is equal to 2 times fact of 1. And fact of 1 is equal to 1, right? And if you notice, the whole way as you're going down, right, as you're calculating, as you're going like 4 times fact of 3, as you're calculating each factorial, you're going to the next one, right? For example, 4 times fact of 3. When you say that, right, when you're returning 4 times fact of 3, you actually don't know the value of fact of 3 then and there. You're just returning that. So what this is trying to say is that you actually don't know the value of fact of 4 until you go all the way down and you come all the way back up. So actually at fact of 4, when it's equal to 4 times fact of 3, at that point you don't know what fact of 3 is, because you know that fact of 3 is equal to 3 times fact of 2. And then you don't know what fact of 2 is. So then you have to know, well, what is fact of 2? That's equal to 3 times fact of 1. And then you're like, what is fact of 1? Well, fact of 1, is equal to 1. That's where our base case comes in. So our base case tells us the foundational number, which is fact of 1. So we know that fact of 1 is the one that we have set a hard and fast value for, which is 1. So knowing that fact of 1 is 1, we can work our way back up. So therefore, we can know that fact of 2 is equal to 2 times of 1, right? Because it's equal to 2 times fact of 1, which is 1. So fact of 2 is equal to 2 times 1, which is 2. Then we can work our way back up, then go to fact of 3. We know that fact of 3 is equal to 3 times fact of 2. And knowing that fact of 2 is 2, we can therefore conclude that fact of 3 is 6, right? Factorial of 3 is 6. And then if we use that and go back up, we know that 4 times factorial of 3, which is equal to 4 times 6, is equal to 24. So that is how you sort of use the logic to calculate the factorial of a number using recursion.
Mm-hmm.
So
now we can go ahead and actually.
Before we move on, does anyone have any questions about the logic? Hopefully that was clear enough for all of you. If any part of that does not make any sense, please feel free to voice out, unmute, or ask in the chat. Okay, so this will make more sense when we go and dive into the code, which is what Arnav will do right now. So he'll be giving you guys a coding demo of how to implement factorial recursion in Java.
Mm-hmm. So now we can go ahead and go to Eclipse and then actually see this demo. So as Nani mentioned previously, factorial is essentially the product of an integer and all the integers below it. So the first thing we want to do is make our factorial method, which is recursive, obviously. So we say public and it returns a type of integer, right? So public int factorial, and then we pass in an integer n, which is the first number that you really want to pass in. So we'll say, so we'll go ahead and declare a method like that. And then if we go ahead and look at the logic again, we can see that the algorithm is essentially where we pass in n times factorial of n minus 1, where the base case is n is less than or equal to 1. So the first thing we'll want to start by doing is creating our base case. So the way you actually create the base case is with an if statement. So you say if n is less than 1, you want to return something standard, which is equal to 1. So we want to return 1 in that case. And note that the reason that we say less than or equal to 1 is because factorials can't actually go negative. So that's why we always return when we get to that point. We do meet our case. Those are like basically everything else. So we want to go ahead and add an else statement. And then we say, like, if we're not at the base case, then we want to return something else, which is return n times fact, like this. So here's the part where actually like do the recursive call. So we'll say n times factorial of n minus 1. And this statement right over here is actually the recursive call, where we call the method on itself again, so that way we can see, like we can access the previous value, and that adds to our stack. So now we can go ahead and test out our method by saying print out factorial of like 24 or factorial of 6, for example. So we'll say system.out print ln factorial of 24 or 6, sorry. Oh yeah, and then it says we can't actually create a reference to the static method, and that's just an error because since we didn't actually create an object, we have to make the method static. So we'll go ahead and do that. And with the error fixed, we can go ahead and launch this. So here we can see we call the method and we returned, we called factorial of 6 and returned 20 over here.
Yeah. So if we look back at the code, we can see that if the if statement, it says if n is less than or equal to 1, return 1. So that's our base case, and notice how that is in the if statement and not the else, because we always want to check for the base case first to ensure if it's been reached or not, and then if it's not, then we want to go back and do the n times factorial of n minus 1. And if there are any other concerns with this, how it sort of works is when you say n times factorial of n minus 1, it's calling, like for example, if you pass in 6, it's basically calling 6 times factorial of 5, and then we know that factorial of 5 will go back in. We'll call 5 times factorial of 4, and then 4 times factorial of 3, all the way down till it gets to 1, right? Till n is passed in, and when n is equal to 1, it'll go and return 1, and then you can work your way back up to the top. So that's sort of what it's doing right now. So hopefully this made some sense in the code, more than it did in logic. So if you have any questions about this particular recursion or just recursion in general, please feel free to ask in the chat right now. Okay, sounds good. So then we will go ahead and move on to the second one, which is going to be on the Fibonacci sequence. Okay, so the Fibonacci sequence is a very popular sequence in mathematics, and it is defined by the pattern such that Fibonacci number n is equal to the Fibonacci of the number minus 1 plus the Fibonacci of the number minus 2. Fibonacci of the number before it, and then the Fibonacci plus the number of the Fibonacci number 2 numbers before it. So if we look at the sequence on the right, let's say we look at Fibonacci. Let's say we look at the fourth Fibonacci number, right, which is 3 over here. The fourth Fibonacci number is equal to the third Fibonacci number plus the second Fibonacci number, right? So 3 is equal to 2 plus 1, and so on. So if we look at the third Fibonacci number, that's equal to the second Fibonacci number, which is 1, plus the 0th Fibonacci number, which is also plus the second Fibonacci number, which is 1, plus the first Fibonacci number, which is also 1. So therefore, 1 plus 1 is 2. So that's sort of how the Fibonacci sequence pattern is. And it's also defined by the seed values or the constant values, which is f of 0, right? The 0th Fibonacci number is 0, and the first Fibonacci number is 1. So those are your seed values. So we want to create a method, right? If we want to display the Fibonacci sequence through recursion, we want to create a method that will take in a number such as int n, which indicates the desired Fibonacci number. Like for example, if we enter the number 4, it'll refer to the fourth Fibonacci number, right? Whichever Fibonacci number you want, we'll enter that in as int n, and then we will return the value of that corresponding Fibonacci number. So if we say we want to know what the sixth Fibonacci number is, it'll go ahead and return us the value of the sixth Fibonacci number, which in this case is 8. So how will we do this, right? That's where we employ our algorithm, which is n, right? The nth number is equal to Fibonacci of the nth number minus 1 plus Fibonacci of nth number minus 2. So it'll go ahead and find the nth minus 1 Fibonacci number, then find the nth minus 2 Fibonacci number, and then it'll add those two numbers together to produce you the number that you want. And this case, our base case will be n is less than or equal to 1, in which case it will just return n. Yeah, so if n is ever less than or equal to 1, then we're just going to return n. So the Fibonacci sequence, right, in recursion can go a very, very, very long way. It can go a very long way because if you were to pass like the 100th Fibonacci number, it'll have to keep on calculating back and back and back and back and back until it gets to the first one and then work its way all the way back up. So let's go look at what is fib of 4. So the fourth Fibonacci number is 3, right? As you can see, the fourth Fibonacci is 3 because it's 1, 1, 2, 3. So we know that the fourth Fibonacci number is equal to the third Fibonacci number plus the second Fibonacci number, right? So the third Fibonacci number is 2, and the second Fibonacci number is 1. So 2 plus 1 is 3, right, which is the fourth Fibonacci number. But our computer does not know that, right? So it only knows that the Fibonacci of the fourth number is equal to the Fibonacci of the third number plus the Fibonacci of the second number. It doesn't know what the third Fibonacci number is, or doesn't know what the second Fibonacci number is. So once again, you have to go back and then say, well, what is the third Fibonacci number equal to? Well, the third Fibonacci number is equal to the second Fibonacci number plus the first Fibonacci number, and the second Fibonacci number is equal to the first Fibonacci number plus the 0th Fibonacci number. So then breaking this up again, what is the first Fibonacci number equal to? The first Fibonacci number is equal to 1, right? Which is our seed value, and then our 0th Fibonacci number is equal to 0, which is also our other feed value, our seed value. So then using this, we can build our way back up again, right? How we did in the previous example. So knowing that fib of 1 is 1, we can go ahead and calculate fib of 2. So we know that fib of 2 is equal to fib of 1 plus fib of 0. And those two are both our seed values, right? So we know that fib of 0 is 0, and fib of 1 is 1. So therefore, we can go and calculate fib of 2. So fib of 2 is equal to 1 plus 0, which is 1, right? So we know that our second Fibonacci number is 1. And then knowing our second Fibonacci number, we can work back up. Say, well, what is the third Fibonacci number? The third Fibonacci number is fib of 1 plus fib of 2, right? Because it's n minus 1 plus n minus 2. So fib of 1, as we know, is 1. And fib of 2, we know, is also 1. So 1 plus 1 is 2. So therefore, we know that our third Fibonacci number is 2, as you can see. And now we come back to the number that we've been wanting to calculate, which is our fourth Fibonacci number. So to calculate our fourth Fibonacci number, we do fib of 3 plus fib of 2. We just calculated fib of 3, which was 2. And then our fib of 2 was 1. So therefore, we can do 2 plus 1, which is equal to 3, which, as you can see, is our fourth Fibonacci number. The 3 is what is returned by the method. So any questions? Or would you like me to elaborate a little bit more? Please feel free to ask them right now. Okay, so, oh yeah, Arnav, do you want to add anything?
No, I was just going to say if we don't have any questions, then we can move on to the coding demo.
Okay, yeah, so let's go ahead and move on to the coding demo for how this will work in code.
Yeah, okay, so let's go to our Fibonacci class, and here we can see we have, let's actually create a method called public static int, and we'll just call the method Fibonacci1 for this case, and then we want to pass in an integer n, which is actually like the nth term of the sequence that you want. So we'll go ahead and do that. And then taking a look at the logic again, we can see that we can see that the Fibonacci basically has a base case where n is less than or equal to 1, then we just want to return n. So there are actually multiple ways to code this out. So one way of doing this is we can say there are kind of like two base cases for this, where we have if n is equal to 0, then we return if n is equal, looking at the sequence, okay, we actually start with 1. Okay, so we'll go ahead and redo this. So we say the base case is if n is less than or equal to 1, then we just simply return n, which is one way of doing this. So if n is less than or equal to 1, then simply return n. And this is basically if we're saying, this is basically our base case where it might be the first index or the second index. We do just return one. So would be the first two terms as we can see over here. And then otherwise the algorithm is where we return the number before it and the term like 2 before it. So we'll go ahead and do that with our else statement. So we'll say else return, we'll call the recursive call twice over here since we actually return the number before it and then number before that. So we'll say return Fibonacci 1 of n minus 1 plus, again, the second recursive call Fibonacci 1 of n minus 2. And here we're basically just adding the term before it and the term like 2 before it. So that's basically our recursive call. And then here, if we go ahead and print out, in the main method, if we go ahead and print out Fibonacci, if we pass in 7 as our parameter, we can see that it prints out 13, and that's the term at the 7th index of the sequence. So if anyone has any questions about that, we can answer that. All right, so it looks like no one has any questions. Nandu, if you want to elaborate on this.
Yeah, so this is basically what we explained in logic, just like in the code. So once again, our base case is in the if statement, which is n is less than or equal to 1, where we're returning n. The reason we're just returning n and not particularly a 1 or 0 is because we know that our seed values are different, right? Our seed value for Fibonacci of 0 is 0, and our seed value for the Fibonacci of 1 is 1. And therefore, noticing the pattern that Fibonacci of 1 is 1 and Fibonacci of 0 is 0, so the numbers are the same. Therefore, we're going to return n and not like a particular number. So that's just for our seed values. So that's basically the base case right there. And in our else statement, we are doing returning Fibonacci of n minus 1 plus Fibonacci of n minus 2. This is basically what we explained in the last slide, where we went over. This is the algorithm that we'll be using to calculate the Fibonacci sequence. So these are just two examples of how you can employ recursion to make these complex problems a lot simpler and just in a lot less lines of code. And I highly recommend that you all look more into recursion. We do have a homework worksheet for all of you to finish before day 6. So yeah, so just please keep looking over recursion. If you have any questions, please feel free to shoot us an email or ask us right now in the call. But I think other than that, Arnav, if we could go ahead and go to the worksheet page.
Mm-hmm.
Yeah, so you can go ahead and access our worksheet at tinyurl.com/intermediate worksheet 5 for our day 5 worksheet. So please go ahead and visit this link right now to get the worksheet. And you can also submit the worksheet at the same submission link. Yeah, so next slide. So yeah, so that concludes day 5 of Intermediate Advanced Coding Camp with BayTutors. So thank you all so much for tuning in to today's video, and we look forward to seeing all of you on day 6.